Okay, hello everyone. So this is the second week of SQL for relational databases at True. So we are going to start today the logical database model. So which is the chapter 3, but the last class we didn't complete the chapter 2. So first I'm going to complete the chapter 2, then followed by the chapter 3. This is your reminder. So we have a due on the February 5th. So for the project page 1. So probably in the middle of the today's class, I'm going to explain what you guys need to do for the page 1 of the project. And also I'm going to mail out the GCP coupon code probably by the end of this weekend. So you can, if you know how to activate, so you guys do that. It's just a simple the click and enter. Otherwise, you can hold the coupon code by the second, the I think the second exercise left for the GCP, and we can activate together. And the last one is the after the today's class, so you are ready to do the database model, especially the logical database model. For that the modeling, we need the software. So there are several software available for database modeling tool. So I'm going to introduce at the end of the chapter 3. But for your reminder, for the next week, the exercise left, you need to install the either data modeler, which is the RWin software, or the for the MacBook user. So you guys can install the MySQL Workbench. So I'm going to give the more information at the end of today's class. Okay. Any question before I start today's lecture? If you are ready, please give me thumbs up. Then okay, very nice. Nice to meet you, everyone. Then let me. If you have any question as usual, please use the chat box. That is the best way. I cannot check each and every the window right now. I opened 6 or 7 windows. So pretty much I'm going to check the chat box. So if you have any question, please use that. Otherwise, you can unmute by yourself because we have the 12, 13 students. So I think that it may not be a problem if you unmute and ask the question directly. Okay, then let me share the screen for the Moodle. Okay, so this is as usual one more time. So everything regarding to this coursework activity due date and the so on submission, everything you can find all the information about this course from the Moodle. So you can specifically you can check the class schedule by week. So however, the if even though we have a due date the third week, so you guys need to start earlier, like the project page 1 and the one, please check in advance the due date. And also the course schedule is posted here. I tried my best to follow the course schedule, but it may be possible. It's my first time to teach the database course through, so not sure how much I can cover. So this is my best. So if the course, the lecture is behind the schedule, I'm going to adjust later. Okay. So let me also, for example, the today's we have I'm going to use the handout. So it is okay that if you can print out like this one, that is the best for your practice. Otherwise, you can download the PDF file and be ready with the lecture notes. Okay. So let me share the. I'm going to use directly this one. It will be easier to manage. So last time we talked about basically the introduction of the database system. So I introduced what is the data and what is a database, what is a database system. Basically, main objective of this class is to think about we do not have any database system. So is it problem? No, actually not a problem. So it was the 1969 when the relational database was proposed and invented by the Dr. E.F. Code from IBM T.J. Watson Center. Even before that, we had a database. However, think about the normal the computing environment. Are you going to use any database system? Probably not. Even though I have been working with the relational database the last almost 30 years, I never used the relational database for my personal purpose, which means the database management system is for the industrial solution mostly. When we have very large data, then we need something different to structure because memory based or file system based, the data management is limited by the size and also other restrictions. To overcome such a restriction, we are going to use the database management system. So like the Oracle, Informix, DB2, or MySQL that we are going to use for our exercise. So such a system are software. So these software are based on the certain model, which is called the relational database model. So in this class, main objective of this class, I'm going to introduce you guys to such a relational database model. So relational database model include the language like the SQL, as you know. It's a very popular the structured query database language. Most of you guys heard about it, even though you don't know how to use it. So that is a SQL or SQL or structured query language. Not only the language, but database the model provide a way to organize the data. Last time I the analogy, the database model like the organizing my room like the bookshelf. So idea of the managing very large data is we are going to group. So how to group? Similar thing will be grouped together. And we are going to call such a group of data as eventually relation. So actually different name of the relation is the set. So in mathematics, so to deal with the infinite number of the data, so we are going to define the natural number set or the real number set or the something the rational number set. So then even though we never use the infinity number, but we are doing something operation for the infinity number very large data. Similarly, so when we deal with a very large the amount of the data, why don't we consider data as a group? Then we are using something operation like the insert, delete, update, or the query the data from the such a group of data. So such a two grouping to make the very large data as a group, we should have a certain rule or structure that is called the data model. So I introduced what is the data model last time. So what we're gonna do in this the class is basically where is the my pen? Yes. So we are in the we live with the information. So we have such a bunch of information. So everything is information. My room, the temperature is high. I'm not comfortable. That's the information. And this class is so nice. So that is the information about the my class. But that is not such a information cannot be used in the system, computer system. So what we're gonna do eventually in this class is we try to change it. So information to the data and also collection of the data. Eventually, that will be the database. Then this database will be created by the database management system. For example, MySQL or Oracle. But this cannot be done at once. We need to follow the step by step. Think about the when you organize your room like the first let me think how can I organize my room or how can I clean up my room. So first I'm going to collect the database related stuff like the handout, textbook, and homework and project and grouping. And I'm taking data analytics class. So the material for the data analytics, you can group it. So my idea is group by subject. That is the model. That is the rule. So that is called the logical level, the model, conceptual level database design. So first, in this today's class, I'm going to introduce how to do the such a conceptual level, the modeling. So it's a logical database model, data model. Then after you design, after you have the idea of the conceptually how to organize your room or how to organize such a information data. So eventually our goal is this one database. So we are going to model one step close to the database system, which is called the database model. So this is the data model. So we focus on the data. Then this data should be database. So we are going to use database model. Especially in this class, we are going to use the relational database model that I introduced. Then using that model, the relational database model can be database using the SQL, the database language. Like we can create the table, we can insert the data. Finally, we have the database, the system. Then this is not just the entire system, but this can be work for the other application. Like I have the apps application. So this application use database system as a backend. So by considering, excuse me, such a the database as well as the application front end part, this is called the database system. So finally, after this class, after the project, you are able to create the such a database system. Okay. So that's what we discussed at what I introduced the last time. So there are two types of model we can consider. So one is the, as I said, the conceptual level modeling. Another one is the physical level modeling. As I mentioned, you don't have to worry about this implementation model or self-describing data model. So I never seen such a the category of the data model except this textbook. So Dr. E.F. Code, he put Dr. The Elmasari put such a models, you don't have to worry about. You will see such a conceptual level model and the physical level model. So conceptual level model is this part. Okay. So then eventually the physical level model is this. So think about let's go back to the bookshelf analogy. So once you have your idea how to organize your book, so by subject, so that is your conceptual model. Then I'm going to use the first layer of the bookshelf for the database course. So how much? Entire the layer. Okay. So that is your physical data model. Then for the data analytics, I'm going to use half of them. And also I frequently access. The second layer will be efficient way. So I'm going to use this second layer, but half of them. So that is the physical level design of your data. So that is called the physical data model, sometimes low level or internal level modeling. So this will be done using the database management system later. So from time to time, when you search the job, you are interested in the database or the data related to the job. So you can see the 4 years of conceptual level design and the 3 years of the plus the 3 years physical or low level data model, the design like that. So at the time, you guys can understand what is the requirement of such a job description and so on. Here's the question. I do not have any background in computer science. I never used the database system. Can I do the conceptual level design or not? If you say yes, so please give me thumbs up. Or otherwise, just leave it. Okay, then what about the physical data model? Can I do the physical level design without the background in computer and computer science? Please give me thumbs up if you can do that, the physical level design without computer science. Just leave it if not. Yes, correct. So conceptual level design doesn't require the computer or computer science. Instead, What is more important, the requirement to do the conceptual or high-level data model? Any idea? Yes, David?
I would imagine this would come from a high level point in an organization, like with people who understand what the users interact with, what kind of data they create, and what kind of data they consume,
Yes.
because this way they have an understanding of what's close and what's far.
Yes, very nice answer. We can give the clap to the David, so you can use the reaction. So conceptual level design, as David answered, most important part is whether you guys can understand data or not, or the domain. So domain expertise usually do the conceptual level design. However, physical level design, you should understand the how hard disk drive is organized and what is the network adapter and what is the bandwidth of the network adapter. Do I need to use the cloud storage or the what is the memory size? So on. You need to understand that you're the computing environment. However, conceptual level design, more important thing is the domain expert, domain knowledge. Because of that, in the industry, when you are doing the modeling, the job modeling project, such a conceptual modeling will be done by consultant or accounting, the expertise, like the CPA or the something consulting company. They know money flow or business flow or human resource like that. So they understand the what is the organization, what they need, and so they can do the conceptual level design. After that, the computer scientist or the IT expertise or data modeler, they can do the physical level design based on the such a conceptual model. Okay, so because of that, do you think it's just a side story? Which one is more paid? Conceptual level or physical level design? Which one is high paid? What do you think? This one is a high paid, unfortunately. So because but nowadays it's the different story. The more like the think about the we have the technical management. So people who knows the engineering part as well as the business. So if you know both of them, the you guys can do the conceptual level design while you are doing the conceptual level design. You can even consider later that this data can be the historical data. So it's not frequently accessed. So you guys can imagine the later the physical model also. So it is good idea if you nowadays is more and more the even IT is an interdisciplinary area. So not only computer but also business mind and the money flow and the accounting part or finance part and so on. So that is the conceptual level design and the physical level design. So that is the reason actually the a lot of the company, like the financial company, they hire the computer science major or data science major, okay, instead of the business school. The more and more Goldman Sachs and the City Corp, they hired even the computer science only. It was the mathematics before, but nowadays because all the such a model will be based on the computer and the computer software. So our goal is to design the such a schema. The last time we talked about the schema is the description of the database. So which means the database design means to the design, the finalized description of the database. Okay, so this is the example of the database schema. So our goal of the database design is from the information. So your boss gave you the student university information. Then from that information, what you need to do is I'm going to decide the name of the disk. So let's say this is a table because everybody knows that what is a table. So it's a table name and their attribute. Sometimes it's called the attribute, and sometimes it's called the column. So sometimes it's called the feature. So all of them are the same meaning, but the attribute is more formal, the terminology. And while the column is the informal way. to explain the name, student number, and so on. But no matter what name you are using, the such a group of the word attribute will describe the student information. So it's the student data. The student table eventually is to be created as a table in relational database and later. And same thing the course. So when I'm saying formal name or informal name, what's the difference? The formal means it's a formal nice. I'm wearing the informal way. So like that. So formal means more the technical the way. So if you read a technical paper, so regarding to the database, they usually say that it's the attribute or the feature, even the tuple or the some relation name. But if you are using software like the Oracle Informix, they are using the informal terminology like the column name, table name, and so on. So that is the difference. But in my class, I am going to use both the informal or formal terminology. But after graduation, if you join the real project, mostly they are not using the feature. Nowadays more the use the feature, but they do not use the attribute instead of column name or table name like that. But it's the same meaning. So our goal of the schema design is like to have such a the database schema. Then eventually, if we just like the object-oriented programming, so you already did the object-oriented programming before, like the Java. Okay. So what is the how can you do the object-oriented modeling? So first task is using the UML or the technique. You are going to define the class, right? So what is a class, by the way? Class is kind of it's a data structure. Data structure for what? To define the data that will be created on your the memory. So this is the class. So class basically has a two part. One is the data variable. Another part is
Function?
function. Very nice. It's a method or a function or activity. Then what is the purpose of design creating the class? Why do you create a class?
It's primarily a tool for code reuse because you're able to create structures that are then adaptable into more specific or focused ones, allowing you to have like an overall conceptual structures for your data.
Yes, that means if I summarize your answer, the using class is kind of a data structure. It's a blueprint. Blueprint for what? To create the data. In other words, or in terms of object-oriented concept, you are going to create object. Object where? Where do you create the object? On your memory. So this is basically the data that you create in object-oriented programming. So it's a memory data structure. Then you are able to access easily, efficiently such an object using what? Reference address. Because memory itself is a bunch of nothing but bunch of address. Okay. So that is the object-oriented concept, the model. What about our database model? It's basically the same idea. So we are going to find the schema. Schema is the model like that. Okay, the schema. Why do we define such a course and the section and so on? Because we have very large data. So we are going to standardize such a data as, for example, course. We have a bunch of different course, but what we are interested in the course name, course number, course hour, department only. Even though this course has a lot of students, they don't care the number of students in this the design. In the course report, it has only the student number, student identifier, and the grade. So we don't care any other information. So only this information. It's a design, the schema. It's like the class in terms of the object-oriented concept. Then this one, using the class, you can instantiate or you can create the object Like we can insert the database instance, like this data structure is this one and full and the CS major, CS department. So each of them is called the instance data. So by combining database schema and the instances, so this is called the database state. So finally, after you create the data and database, after you insert the data and your database is running, then your database state is established. Then your database is alive. So that is our goal. Finally, eventually, we'd like to make the database state for your data. Okay, so I'm going to start today's lecture with the introducing three schema architecture. So I introduced several characteristics and the benefit of the using database system. So using database system, we don't have to worry about for example, inside the database system, in the computer DBMS system, we don't have to worry about too much the metadata and the information such a thing. Instead, we can focus on what? The something the design like the student name, ID, address, like that. Then this schema, this database design will be created on your DBMS system. So then even though the student has another information attribute like the GPA over here, but we don't have to change the program. Okay, so instead our program still can access the data even though your schema is changed. That is called the program data independence that I introduced during the chapter 1. So and also this can be the data, student data can be viewed as the security purpose, also academic advisor purpose, and what else, the bursar office can access the student data. We don't have to create the student table, student database separately. Instead, we have only one student database, but it can be viewed many different ways. It's a concurrently can be accessed by the many different users. So this is called the multiple view of the characteristic that we discussed the last time. So people thought about that. So to support such a characteristic of the database, the system, if somebody like you and me or the company would like to develop the new database system, we'd better have something standard of such a database system. So what kind of the standard? So ANSI define the schema. In terms of schema, the ANSI standardized the database architecture. That is called the three schema architecture. Let me show you the three schema architecture first. So three schema architecture of the database structure include first conceptual level schema. So conceptual level schema means so like the student table has the name, ID, and address. So it's the conceptual level. We don't use any database system. We don't use any computer system. We don't use any the technique, just conceptually design. So design means it's the schema. So it's a conceptual level schema. So, but this conceptual level schema should be implemented so physically. So how? Using computer system, when you design the student, then I'm going to create the student table on computer system, in our computer system. So we don't know how to create yet. Later we will see such a command later. But in this, the example, just think about the student table will be created under /db HDA1, and under the HDA1 is a student folder. Then we will have the student data under the path, okay, file system. So, or So when you create a student, the size is 1 terabyte. So we are going to allocate the 1 terabyte to the storage, like this. Then at that time, such a design, the structure and schema is called internal level schema. So second part, database system should have internal level schema. Okay, then the third one is external level schema. External level schema means we don't have just I introduced before. One table can be viewed differently depending on the security, depending on the permission. So how can we do that? We the database system allow the different view of the same data. So from the bursar office access name and the social security number. However, the academic advisor can access the name and the GPA like this. Even though you have the conceptual level schema, it can be viewed differently. So database architectures should support 3 different levels. So here is the question. So when you are doing database design, like the just before, when you are doing the database design, so which level of schema level design? Is it the conceptual level or internal level or external level? Like I designed the student has the name, ID, address.
Like conceptual level?
Yes. So we are doing conceptual level design. Then after you learned how to create the table using MySQL database, you create the student table using this conceptual level design. Whatever the command we didn't cover yet, using the SQL, you create it. Who is in charge of such a internal level design and schema to create the real table? Who is in charge of that?
IT,
IT? Little bit detailed specifically.
DBA,
DBA use what?
um, database management system.
Yes, right. So DBMS actually should be in charge of such a internal level schema. Think about I create the file on the laptop. Then do I know where it is created? I don't have to know. Okay, because it's hidden. The operating system is in charge of that. So database is the same thing. The internal level design will be managed by the DBMS system, and the conceptual level design will be your job, your responsibility to design. Then what about the external level? How can you implement such an external level the schema? It's interesting. So what the DBMS database guys that did when they designed this one, they used this kind of virtual table. It's a virtual table. It's a fake table. So they actually create the view of the database object. So you have the student table, but you can create the student one view or student two view. It's not real table. It has only the schema. The data itself is just one student table, but it can be through this way you are able to access the data. So this is the view. So later when we talk about the SQL and the database object, I'm going to introduce how to create the view. So three schema architecture is ANSI standard. Most of all database system provide this the different level of the schema, internal level and conceptual level and external level. Because of this one, we can implement what? The independency, like the program and data independence. Even though you migrate the data from here, disk 1 to disk 2, conceptual level design will not be changed. Okay, so even though you add one more column here, like this one is the social security number, your view will not be changed. Okay, So this is the benefit of the three schema architecture. Most of the database system architecture, they follow this one. So that preserve the logical data independence, physical data independence. So physical data independence means that this relation, and the logical means that this one. Okay, so I think they're almost done for the chapter 2. So database, I think that I mentioned several times the name of this SQL. So SQL is structured query language. So actually, unfortunately, the computer system cannot understand any program language. I mean the natural language. So we are here, but computer is here. So computer can understand the only machine code as we discussed the first time, the last week. So it's the machine code, assembly code, or it's the binary code. But the human being can understand only the natural language. So we need to bridge the gap. How? At that time, we are using the program language. Similarly, database is the software. It's running on the computer system. So they definitely cannot understand what we are saying, what we are asking. So we need the program language. What kind of program language? We need a specialized one for the database. That is called the SQL structured query language. There are benefit and pros and cons on the SQL. SQL benefit is a very fast and useful to access the relational database model data. And also this one is easy to learn. It's not, I think a day is the pretty much enough for you guys to know how to use the SQL. However, there is a cons. There are several cons. So SQL is not the procedural language. There is no if then else. There is no start and end of the program. Instead, it's the language to access the database only, which means no graphical user interface, no front end part, no procedural part. So because of that, we need to use the other program language like the C, Python, or Java, and so on. So that is the problem of the the SQL language. And there are some others. So this is the SQL. We will discuss later more detail. So such a SQL, structured query language, database language, has mainly two parts. So one is the data definition language. Another one is the data manipulation language. DDL means you can create the data structure, like the creating table, creating the view, creating something. So creating and or the modifying or the removing the data structure. At that time, so you can use the data definition language. However, if you wanna deal with the data, like the insert, as you know, there are four basic operation in data structure: CRUD, the create, read, update, delete. The database also supports such as CRUD, the insert, update, the delete, and select the data. It's so called the data manipulation language. However, it is true that when we are saying the SQL language, that means the data manipulation language. But eh, Professor Lee said there's no if then else in SQL. Then what if I want to do such a conditional statement? So SQL itself doesn't support such a procedure. If then else or conditional statement, no for loop, no while loop, no if then else. Then how can I do that? One way is you guys need to use other program languages like the Java, C Sharp, or the .NET, and so on. That is one approach. Another approach is DBMS provide something part of the procedural language part. So for example, the Oracle has the PL SQL, the procedural language for the SQL. And the Informix and the MySQL provide the PSM. So procedural storage module. I cannot remember what M stands for, but the PSM. So like the procedural part of the SQL. But This one is not frequently used. You can use, but there are several issues like the efficiency and the performance. So not much use, but in this exercise, I'm going to introduce a little bit about that part. Okay. There is another one in addition to the DML and DDL. It's called the DCL. It's not major thing, but control language. So data control language means it's a control like the grant the permission or revoke the permission, make the group of the user or something like that. But I'm not going to cover the control language part in this class. But it's not complicated, so you guys can catch up by yourself after this class. Okay. And there are different types of the database programming. So which means the way to combine with the other program languages. So embedded, procedural call, and so on. You don't have to worry about right now. So we will deal with this one in chapter 8 and 9 later. Okay. So almost done. We have the functionality and utility of the DBMS system, like the backup and recovery, or restore, or the excuse me, the bulk load, or the import, export, performance monitoring, and so on. But if you take a look at this functionality, it's very similar as what? Can you find any the computer related component that are very similar as this? It's similar as this guy. So operating system. So operating system, you can tune, you can actually back up, and you can report and such a thing. So one time, it is a funny story. The Oracle, as I show you the last week, Oracle is the top market share, the database management system. Then when you install the database system like the Oracle industrial, the level of the database system, you are going to use the computer server only for the database. So we call the database server. So then, but there's no way to use the database system without operating system. Definitely you need to install the operating system. Then on top of that, you are going to install the database management system. So database is the software level, like the Microsoft Word or the web browser, like that. However, so think about the Chromebook. Is there anyone who uses the Chromebook? Anyone? What kind of operating system do you use the Chromebook? Chrome itself is the operating system, but that is only interface. Through the Chrome web browser, you are going to do because most of the application are cloud. So kids like the elementary student kids or the middle school kids, they don't have to install the other software. Instead, through the web browser, they can use most of the application on cloud. So that is the idea of the Chromebook. So you don't need the operating system, which means it's much simpler. Okay, then the application can take care of everything. So you don't have to worry about the IT admin. So you guys still want to do everything. So bypass the IT admin like that. So Oracle thought about the same thing. So operating system is too bothering a lot. So why don't we take out the operating system? Because as you can see over here, most of the functionality is the same as the operating system. Why not make the Oracle database as the operating system? So there was a project in Oracle. They tried to build the Oracle operating system that include the operating system plus database system. Do you think it was successful? They failed. Because think about how many different types of the processor and the board, and really a lot. So unless the Apple style close the business, right? So the Oracle, once they launch, so it's really a lot the housekeeping job to bug and debug and the maintenance that finally they gave up. But it is true. Database is like the in between application and the operating system. It's the kind of the system because of such a characteristic. Okay, so eventually in this the database management system, we are going to touch the definitely data the query and the data definition language, and also we will do the database programming, the application part, and also I'm going to introduce the query compiler, query optimizer, and eventually the concurrency control and the transaction management, and as much as possible in this class I'd like to give them more experience on the database system. Okay, before we conclude the chapter 2, this is I'm going to quickly introduce the computing environment history in terms of a database system. Long time ago, like almost 40, 50 years ago, our computer system is like this. So we have database, we have the interface, we have the print output, we have all the component in one system. So this is called the centralized system. Like for example, IBM, the mainframe. Have you ever heard about the mainframe? I think some of you, which means you are quite old. So it's old, the architecture. So, but it was a popular still. Some of very few financial industry, they still use such a IBM mainframe style, the centralized system. Benefit? What is the benefit of the centralized system?
It's secure.
Secure, because no connection. It's isolated. Even when I have used one time, it's a 1993 4. So to connect the database system, I need to connect with the CIT monitor. It's a dummy terminal. So dummy terminal means it's just a plug-in, directly plug in the system and the CIT monitor green star. So no way to be hacked unless the user is the problem, right? So this is a secure, but the biggest problem of the centralized system, and also is pretty much the good performance because no overhead like that, no network. But the problem is
Like limited space?
which means it's a full of the data. Then what happened? It's not flexible to use.
Nothing.
So we cannot do that. So we need to buy the new one, bigger one. So like this size, the centralized system, much expensive. It's a much more expensive, and also you need to migrate. It's really the annoying job, such a migration. Think about you migrate from home to the campus. So it's not easy though. So that is a problem. So people try to solve that problem in 1990. How? So why don't we take out some part of the job here? So this part is for the small computer. This part is a small computer. This part, small computer. Then the centralized server has the only database. Then you are going to take out some part of the job from the centralized server to the what? Personal computer.
Application servers.
Yes, the application part. Application layer will be taken out. So 1990, what happened? Personally, I purchased the computer first time 1980, but at that time I didn't know much about computer. But the 1990, mostly many of the houses, the home computing started. So even though it was expensive toy, people try to buy the personal computer because the personal computer power has been increased at the time. Also, high-speed internet started. Think about when did the Yahoo found? When Yahoo founded, it's 1992 or the 1993 at the time. So because of internet network and the PC power, so we can downsize. So downsize of computer system. It's a downsizing. So during the downsizing, actually, I found the first job. At that time, it's a huge the business, such a downsizing. So this is called client. These are the client, and this is the server, database server. If we are using database, it's a database server. If we are using web server, it's a web server. Okay. If we are using file server, it's a file server. So it's the client and server environment. The centralized server environment moved to the client server. Different name of this client server is called what? It's a two tier. One server tier and two the client tier. So it's called the two-tier system. So benefit. What is the benefit of this?
It's easy to expand.
That's correct. So you can just replace the database system. And also, if you have more user, you can connect the client more. Okay. Then there are more the benefit, but let's move to the problem. What is the cons of this one? It started security issue. So, but we are not going to deal with the security part here instead. So what happened? Did you take the have you ever did the network programming like the socket program, TCP/IP program? So what happened when you make the link of the client and server in memory?
There's latency issues.
Latency, and also you need to allocate the space on the memory. You need to create a process anyway. Whenever you connect the socket program, so think about the TCP/IP protocol. So web server. So I'm going to use the web protocol, HTTPD. The port number is 80. So I request that what happened in the system server. Memory will be allocated. There will be process to be in charge of such a request. Then request is I need the index.html. Then index.html will be returned to the client. Then you can browse index.html using browser like that. So which means it needs resource. So specifically memory resource. Roughly, whenever you connect the database, like for example, Oracle, so you can connect the database, then at least 10 megabyte of memory will be used. One connection, 10 megabyte. Then what if you have 100? It's a 1 gigabyte of memory. What if you have 1,000? So the old company has 3,000 employees. So 3,000 times the 10, it's a huge memory size. At that time, 1990, there's no such a computer system to support the 3,000 users. So we cannot create an unlimited number of clients. So how can you address such a problem? This is a two-tier. So how can we address such a two-tier problem?
Web-based interface.
Add another interface. You are saying adding the interface?
Well, I'm just thinking like create a web server and then go through the web.
So web server, yeah, that's good. The web server is here. Then we have the client browser. So you can request the web pages. So it's a two-tier, basically the two-tier system like the DBMS web server, email server, printer server, file server. It's a two-tier client server environment. But it's a limited. Nowadays, how do you call the web server? Do you use the name of a web server? I don't think so. Nowadays, we are saying application server, right? So what is the difference? The web server and application server? Yes. David.
Well, a web server is more classic, like it creates processes and has some kind of internal data and sends requests and receives them.
Mhm.
But nowadays, when you do programming, like the application layer abstracts a lot of that stuff away. So instead of literally working with requests, you're usually going to be writing like view functions, which do these expected things for you.
So web server more the focus on the server part, classical the approach. Application, the server more interested in the application layer. Why? The reason is like this. So when we have a huge number of clients, the server side cannot afford it. So, but the problem when I check the connection like the 3,000 users. So think about my old company had the 3,000 employees. All employees when the coming in the office, they log in because they should check in to the manager and the company. So we have the 3,000 connection to the server. Do you think how many of them are actively working among the 3,000? How many of them are working among the 3,000 the connection?
Could you repeat that?
So how many the connection? So let's say that we have the 3,000 the client over here to the database server. Then among the 3,000, how many of them are actively working or doing something?
10%?
10%. That means the 300. Surprisingly, when we check the active the client is the 5 to 10. Because think about the computer system. Even though you have the one CPU, so you can run many processes, many applications, right? So same thing in the server and the client, only few number of them are active. So why not? We are going to put something in the middle. So 1, 2, 3, 4, 5 process. They are connected. It's a dedicated to the server. Then client actually use the available the connection. So I need the customer information. Then this one is not being used. So select this one and get the data and return. Then this will be available. Then the other user, so active user request find the available one, then the connect. So this one is the connected. So this is called the application layer. It's the middleware. So sometimes this one is called 1, 2, 3 tier architecture. Nowadays, web server include this application server also. So nowadays we call the application server instead of the web server. So this is the 3-tier architecture. Nowadays, the many of the database system use such a 3-tier architecture. Okay.
Could I ask a question?
Yes.
So is this three-tier architecture more or less synonymous with like model view controller architectures?
Yeah, very similar, but this one we need something. It's not modeling issue. This one has the specific the software to connect the database and also it's a balance the transaction. It's a transaction management.
So it's like MVC, but not
Yes.
exactly.
So it's still called the TM monitor or the TM. There is a different name, but basically, so this one is used for middleware between client and server. So to manage the transaction. So this is a 3-tier architecture. So in the project later, even though it's optional, so it is good idea to think about what kind of the architecture you are going to implement in your project, like the Drew registration system. So mostly it will be client server environment, which means your application program will be client, and you are going to create the server, then directly connect the database like that. So this is the client server environment. But if you can use like the for example, I've studied for the application server, like the Apache server or the something the Microsoft the server. So you guys can consider such an application layer server for your the project environment also. Okay, so that is the 3-tier architecture. So 3-tier include the middleware application, or the nowadays web server include the application server part. So this is the computing environment. History of data model and database model are also a very interesting topic. But I'm going to introduce from time to time later the history of that. So what is the oldest database model, and which is the hierarchical model. Still hierarchical model being used in the market, and the network model, and so on. So, okay, so that is the end of the chapter 2. So let me open. Lecture note, chapter 3. So there's a question. The self-describing data model is a JSON, an example of this. So when we are saying the self-describing, so JSON is the format, data structure for data communication, specifically for the Java-based JavaScript. But nowadays, such a format can be used for the data format, specifically the document database format, because it has element and the data style, value style, the format. However, when we are saying the self-describing data model is the self-describing is the characteristic of the data. The metadata, the data structure itself is included. Think about that, the XML. So nowadays, the XML is not popular, but the XML is more flexible than the HTML in terms of markup language. But the problem is you need to define the tag. So that's the describing, that's the metadata. So database itself include such the metadata information as a format of the relational database model. So that is a self-describing data model. But it may make sense. You can use the JSON format for the the data structure for the self-describing data model. That may be possible. Okay, so let me open this. So what we're gonna do in this chapter is we are going to start the database design finally. So it is good idea if you can print out the handout, the chapter 3. So the first, or you can pull out the PDF file from the Moodle. Okay, either way is fine. So you can see this one if you can find. So either way is fine. Let me show you this. So I like this diagram. It's from the textbook. So why don't you take a look at this? Oh, by the way. So I'm going to share the screen again. Okay. So I like this diagram a lot in the database class. If you take a look at this diagram, are you familiar with this diagram? Why don't you follow from the mini word to the internal schema and the application program? Why don't you follow the arrow, then see whether you guys are already familiar with this the flow and the diagram. I will give the 1 minute to take a look at. Okay, so what do you think? Is it new one or have you ever seen or at least are you familiar with the flow of the diagram? What do you think?
The right side a little bit, yeah.
And what about the left hand side, this part? What do you think?
Not really about the lower level stuff,
Uh-huh.
because usually you just use like a pre-made
Mhm.
framework or something.
But if you are taking the programming class like the Python or the C++ or the Java, I do not know exactly which the class will be offered at DU, but most of the instructor assign the programming for your the practice like the problem. Then that is the requirement of your function in your program. Then you are going to understand what is a requirement and try to analyze such a program. Then the design the data structure, like which one will be variable, which one will be the array, and is it the for loop, while loop, such a thing. Okay. Then the implement the application program design. Then finally test like that. Actually, the left-hand side part, this flow is not new one. You already did many times in your application design and process. Then we already discussed the right-hand side. The right-hand side is for what? If we take out the data part from your functional design or the application program design part, actually this is the data part. Then replaced by the database design. Instead of designing the variable or data structure, why don't you replace by the database design? Then if we can plug in like the conceptual level design, it's not related as we discussed before, but once we design and implement, then this one will be plugged in to the application part. Then back and forth. So also, if you consider the number of transactions of the application, so you need to consider the different scale of the physical level design of your database, like that. So the designing process is not separated from the application program. So it's a very close. Sometimes it should work together with the application level design and the process implementation with the database design and implementation and test part. So I like this one because some of the students who are just start the database design, this database is a separate one. No, database eventually work with the application program. Okay, so it should work together. That is the reason I do not require application implementation in your project, but eventually you should be able to implement the application so as a backend database like that. Okay, so we are going to start the first such a conceptual level design. The conceptual level design, don't worry, I do not have background in programming. Don't worry, I do not have any the programming. Don't worry. So we are going to start with the conceptual level design that doesn't require any the programming part. Okay. So from now on, throughout the semester, I'm going to use two the very basic and simple database. So one is this. Let me change it, the screen share with not this. Oops, It's my mistake. So where is it? Handout. Okay. So I'm going to use the two sample database in my course, in this course. One is this one, the company database. The company database is very simple and everybody understand, even though you never got a job in a company, but you guys can easily understand that this company database. So from now on, from time to time, I'm going to use the company database as a sample database, specifically the database for the database design. Then second thing is later, I think the end of this handout, so you can see that this one. Wow, it's really the long the description, but it's a university database because you and me are in the university, so everybody can understand what is a college, what is an office, what is a department, what is a major, minor, and so on. So I don't have to explain details about this. So if you just read quickly, everybody can understand. So for example, the one is for freshman, two is the sophomore. So I don't have to explain this one. So these, the university database and company database are the basic sample databases used in this class. So you don't have to worry about too much the meaning of that, but because of the simplicity, so I'm going to use this one. So in this the logical conceptual level design data model, I'm going to use the company database. Then also for the logical level, the database design, the conceptual level design, I'm going to introduce the ER modeling. So such the logical or conceptual level design, first level design. So for example, here, the conceptual level design, there are many different approach, many different conceptual level design. Among them, the most popular and the easy and the flexible data model is the ER modeling. So E stands for the entity and R stands for the relationship. Entity relationship model as a conceptual level design. Conceptual means it doesn't require computer part, just conceptually design. Benefit is easy. So even though you don't know, and before you guys know about the ER model, in your life you already used this ER model. So think about if your mom and dad ask, why don't you clean up your room? Then how can you clean up your room? Just collect the similar things, right? The book and the handout and the something stuff. So nobody want to put everything in one box, or nobody want to just mix up. Just want the similar thing get together. So that is the idea of the ER model. So ER model can be used for data model and the programming model, and it can be used for many other modeling. So that is a benefit. So let's see how can we do the ER modeling. So I'm going to call your name. So please read the bullet by bullet. So if your name is called, so I need a little bit rest to save my voice. So Alexia, can you read for me the first line? The company is organized here.
The company is organized into departments. Each department has a name, number, and an employee who manages the department. We keep track of the start date of the department manager. A department may have several locations.
Okay, thank you very much. So you are the modeler, data architect. So you have a meeting right now with your customer. So your customer said the client said my company is organized into blah 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 this. So they are explained to you to ask model this database. Okay. So this is the department information, blah blah blah, right? So any difficult part to understand? I don't think so. I tried my best to simplify and even textbook. So this is the information about the department. Second, so next in the June, the gallery view. Next is the David, but unfortunately David is not there. Oh, here, there. Oh, okay. So David, can you read the line for me?
Of course, each department controls a number of projects. Each project has a unique name, unique number, and is located at a single location.
Okay, which means this company has the project, but this project is controlled by the department. Then the project has a blah 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 information. Okay, that's good. So no problem so far. And third one by the Patrick.
We store each employee's social security number, address, salary, sex, and birth date. Each employee works for one department, but may work on several projects. We keep track of the number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee.
Okay, thanks so much. This information about employee. Yes, it is true. In a company, employee is the biggest important the part of the company. Okay, so we should take care of this employee information to model. And next, the last one in the June gallery view. Ellie, can you read for me the last one?
Each employee may have a number of dependents. For each dependent, we keep track of their name, sex, birth date, and relationship to the employee.
Okay, so suddenly jump into the dependent of the employee, but don't care because so your customer ask you to design the information as a data model. Okay, so these are the information about the company. So in real life, the project. So here's the question: does the customer provide such information or not? What do you think?
No.
Absolutely not. Nobody. This is already organized, but this is for practice purpose. In real project, the customer will give the only bunch of file. Nowadays, it's not printed file, but when I started my first job, it's really printed file. Then it's a folder. It's huge. But nowadays, it's the computer file. They give the Google Drive or USB like that, or the backup device. But this is the kind of the ideal case. It's really for you to focus on the ER modeling. So it's well nicely described. Okay. In real situation, it will be just a bunch of data, like the Excel file only. You guys need to understand from such a number and the column, this way. Even that's not done yet. Based on this one, we are going to start the ER modeling. The first thing of the ER modeling is to find this one, the E. Where is? Oh, I cannot write down here. So let me change the screen share on or this one. Okay. So first step of the ER model is to find the E entity. So before we start, what is an entity? What is an entity? Entity means it's something.
Like object.
Yeah, it's the object. It's a thing. It's a thing. Thing one, thing two, thing three. If you go to Disneyland, you can see but when it was I think 6 or 7 years ago with my child. So when I visited Disneyland, Orlando, so some of the family is just wear the shirts like the number one, number two, thing one, thing two, thing three. It's a family the uniform like that. So entity is just a thing. Okay. So what we're gonna do is to find the similar thing, existing thing. That is called entity. So our first thing is to find something from information. there are a lot of things here. So like if you take a look at the description again, description of company database. So it's like there is a department, there is a manager, there is the start date, there is a department and the several locations. There are a lot of things. From the thing entity, we try to find something important thing. If you see the real data, it looks like instead of this one, the probably department name, like the HR over here. And there is the department number code, and manager like the Lee is the manager, and start date, and some locations like New York and Boston, and we have the LA, like the location, like this. It may be Excel file, it may be printed, but there might be IT, and it's John managed, and start date is the January 1st, 2000, and it's located at Dallas. It's like that. So you have bunch of data from and also you have the project, the file. If not well organized, even mixed, all the data in one file like that. So what you're gonna do is to find something. Here, these are the department information. So you can define department as the entity first. So what else? Can you find any other entity from this company description?
Projects.
Project. I think that you already realized that I used the capital letter. So next one. These are the employee information. This is a really, really easy case. So do not imagine the real problem is like this one. Okay. This is the first problem. So to help you, but we can find the next one, the dependent. So first step of the conceptual design modeling is to identify such a entity from a description or data. So we can find the department, the DEPT, and also we can find the project here, and also we can find the employee. So we can find the dependent. These are the entity. Actually, so these are the entity. Entity can be found. Entity is the one thing. So this is the entity, and this is the another entity. Okay. Then, if we group the similar entity like the department number 1, department number 2, department number 3, so this is called the entity set. So entity set. Okay. Then entity set, for each entity, it has something, the information like the department number, and this is the department name, and this is the manager, and this is the starting date, this is the location. So then this is called the entity type. So what we're gonna do is actually we are going to find the entity type rather than entity. Entity is actually real thing. It's one object. But what we wanna do is from the number of the object, number of entities, we wanna find such a entity type. So entity type can be explained by attribute. So next step is we are going to find the attribute of each entity. Actually, that is the entity types. So from now on, I'm going to use the interchangeably entity and entity type. So group of entity will be entity type. That is true thing. But from now on, I'm going to use the interchangeably. So entity and entity type. So how many entity types in the company database? 4 of them, right? So, but it's not the easy to understand, but if I draw the diagram like this, it's much easier. So from now on, to represent the entity type or entity, I'm going to use a rectangular like this. Okay, so for example, rectangular. So rectangular. And also rectangular and rectangular over here. Okay, so we found the full entity or entity type, then draw the full rectangular diagram. The next step is eventually we'd like to describe this entity type, like the department. So which means we are going to find the attribute of each entity type. So for example, so each department has, oh, right now, you don't, please not just watching the monitor. Instead, why don't you bring any scratch paper or the printout? Then follow me to draw the diagram. It's just for your practice. I know that you are smart, so you can understand all the thing by watching the video, but more importantly, you do better, the practice. So handwriting is good enough. So if you want to use software, it's fine, but you can just draw the diagram by following me. That is the best practice to do. That really happen even the real project. Sometimes if you the encounter very sophisticated problem of database design, people use the handwriting. They draw the diagram on the scratch paper like that. So why don't you use your pencil and the paper, then follow me the step by step. So first step is finding entity type. Then draw the diagram like this. Okay. So for example, department, each department has, if you read this description, has a name. So we have a name here. And the number and the employee number. There's a number, NUM. And there's an employee who manages the department. So we have the manager. And we keep track of start date of the manager start date, START. And department may have locations, so LOCS. Okay, so we found any other attribute? Can you find here? Any other? Probably these are all the attribute. Then just like this one, we are going to use circle. Actually, not circle, over. The over to represent the attribute. So which means so LOCS and name and num and manager and start date like this one. Then we don't know whether this one belongs to EMP, this one belongs to department. So the corresponding entity type, you can connect it. Okay, very nice. So can you guys follow me? So it's just a simple diagram. So what about the project? Why don't you find the attribute from the project? Each department control the number. Control is not yet, so you can say the control project. Control. And each project has a unique name. So we can put the name. And we can put the number. It's a project number. NUM. NUM or NUB. NUM. And located in single location. LOC. Then just like this one, you guys can use the over for each attribute and connect it. Like this. Very nice. So why don't you continue for the employee and department? Okay, I will give the couple of minutes, then we will see together. I'm going to do by myself also. So employee social security number. and the address, ADD, and salary, and sex, and the DOB, birthday. DOB is this sign. And circle or over, and connect. And dependent, each employee, let's say that each employee works for one department but may work on several projects. Attribute, it doesn't look like the attribute. We will see together. Each employee may have a number of dependents. For each dependent, we keep track of their name and sex and DOB and relationship and the employee name. So we can this, relationship, and this.
Wait, I'm sorry. So
Yes.
for the part where it's like number of hours per week that an employee works on a project, is that in terms of representation like connected to the projects, or is it its own bubble?
What do you think?
Well, to me, it seems more intuitive for it to be like a field offshoot, but I would imagine that it's probably more complicated that way.
Yes.
So it's its own bubble.
Why don't we set aside complicated part, right? So there are a lot of controversial issues on this diagram. There's no general solution. So we will check the one by one, okay? So can you guys follow me? So if you think it's complicated, just set aside. We will see. It's just a step by step.
I just have a question.
Yes.
For the project box, what are the 4 types? Like I have location, name, and number. And you have 4 there. Like, what am I missing?
Let me see the project. It's a control. One is the name, the number, and the location, and it's a control department. It's a control department. So it says each department control. So I'd like to put. So I'm saying that my answer is not correct. I'm not saying that my answer is correct. So, but I tried my best, like to put all the information as an attribute. So control, so control things as an attribute. We will see later. Actually, there will be solution later, but you can just put as an attribute.
Okay, thank you.
So to go off of that, this would be an example of where you would have like be deciding between a foreign key or a
foreign key is
relationship.
Too far. So forget about the foreign key right now. Okay, foreign key is really, really too far. It's like we'd like to go to the LA, but we just started. So we just out of the New Jersey. So it's still far away. So and eventually, but we don't know. Just forget about the foreign key. Okay, so let's see it together. Okay, so there are a lot of different answers. Up to the step 2. For example, each department has the name, number. This might be okay, but what about the manages? So manage can be the attribute, but I'd like to put the manager's name as an attribute. So manager here. So it's not clear whether this is the attribute, but I just put the attribute. Similar thing happened project like the control department. If I remove this part, I do not know how to remove the eraser. So for example, if I delete this one like this, but it's clear the 3, the attribute, they are the attribute of the project. But what about this information? Department control the number. So there might be department information that control the project. So we may lose some information later, but eventually later that will be. So department is here. So we can borrow the department information to the project as a relationship later. but we are not going to touch that part yet. So it is okay. So your answer can be different. So let me, what is the writing? So this is the writing, not this one. I'm here, the throw. So you can put the control department over here if you want, and the so on. Same thing. The employee, social security number, address, salary, sex, and birth date, definitely attribute. But what about the employee works for one department? So do I add the department for the employee? But that department is here. So you can set aside that part also, and so on. So this is the currently my answer, but I'm not saying this is correct one. So we are going to the massage later. Before we move on, so there is one more thing. So if you see the attribute, there are different types of attribute. For example, if one attribute has the one value, that is called the single attribute. It's a single attribute. However, sometimes one attribute has the multi-valued, attribute. Can you find such an example of the multi-valued? Several locations, you can see the clearly plural. So, which means, so the location can have the multiple the value. So at that time, instead of a single circle, we are going to use the double circle like this one from now on. If attribute allow the multiple value, then we are going to use the double, the over like that. So single, definitely this one. So there is another type of the attribute possible. So let's see the address. There might be address. So which one has the address? So employee has the address. So address can be just like the address here. However, if you think about the address has the zip code and street information and state information and also town information. Then even street information has the street number, and also this one has a street name, and this one has the street, the type, like the road or the avenue, like that. So the attribute can be split into the details of the attribute. So at this time, this kind of attribute is called the composite attribute. So composite attribute, if you can split into the detailed information, you can use the over as a child, like this one. So any other example that can be composite? Can you find any other example? If you want a birthday, can be composite like the day and month and year, like this one, right? Then here's the question. Which one is better? So for example, the address, composite or single? Which one will be better? What do you think?
Composite.
Composite? Any other opinion? Everybody agree it's a composite? So such a decision is depending on the requirement. So we cannot say which one is better than other. Instead, based on what? Based on the if you open the first page of this one, so you can see the left-hand side, the left-hand side is application analysis, this part. So if your customer asks, we are going to manage the customer by the G code, then you need to separate the Z code like that. But if your customer want to just manage address in one form, you don't have to. So it depends on the requirement. Same thing, birthday. If you just manage the birthday as a one, the DDMONYYY1, then that's it. It's a one form. However, if you want to manage the customer by the year or the something months, then you are going to split into details as a composite. So who decided?
Customer.
Customer do not know anything about such a modeling. Because of that, they are hiring you. So you are in charge of that. You guys, as a data modeler, data designer, you need to decide based on the requirement. You need to clearly understand what is the requirement of the customer. Then you guys decide. So in this case, the single is better. In this case, the composite is better, like that. Okay, there are a lot of such a thing. Sometimes the department can be attribute of a project, something like that. Or the project can be attribute of a department. That may be possible. But in this case, obviously, project can be separate as an entity. Who decide? You should decide. Okay, considering requirement and also performance. Because of that, database design require a lot experience. It's a practice. Okay, very nice. Then one more thing. Sometimes if you read the description or if you take a look at the data, it has the, for example, here, the unique name, the unique number. So what is the benefit of such a unique name and unique number? No data. What if you have a unique number? What is the benefit? It is good for what? Search the data. If the data is unique, I can just call your ID, then I can find it easily. But if all my students are using the very popular name like the James or the Kathleen like that, the popular name, it's not easy to recognize who is whom. So when you search the data, so if data is unique, then it's really good to find the data. So especially in a database, we want to search a unique attribute, unique value of the attribute. So it can be used for what? It is called the key attribute. So it is the good idea to identify the key attribute. Later, this key attribute will be used for the key to search the data. So if you can find such a key attribute, in other words, a unique value of an attribute, underline. So for example, so company has a department, each department has a name, number. So do you think name is unique? Employee name definitely is not unique, but even though it's not saying the unique department, I think the general case, no company use the same department name, the common department name, right? So it may be possible, but it's not clearly say the department name as a unique. So, but obviously number will be unique, so we can underline. Also, project is clearly say the unique name, and the unique number. And what about the employee? Employee is the social security number is definitely the unique, so we can underline. What about the department? A dependent. We cannot say the dependent name is unique, right? So my son is Nicholas. I can at least find at least one Nicholas in any group or any class, right? So we cannot say the name is unique. But it may be possible if we have the employee. So one employee may have the unique name of dependent, right? The family. So if that is a higher chance to be a key, you can underline. So it's the possible key. So you can use the dot underline for the possible key. It's not unique yet, but if we combine with the employee, the dependent can be the unique like this. So here's a question. How many key attributes can you find for each the entity? How many? How many key attributes can you find for each entity?
It has to be one, right?
Has to be one. Any other? Just to see. So how many key attributes for the department? It's one. How many key attributes for project? Two. How many for employee? One. How many for dependent? Zero. It may be possible, but not. We cannot say it's a unique. So key attribute can be 0, 1, 2, many. Depending on the entity type, sometimes you can find one entity, one key attribute, sometimes multiple key attribute, sometimes 0 key attribute. It doesn't matter. However, if you already use the database, have you ever heard about primary key? So anyone who heard about the primary key, so give me thumbs up before. Even though you don't have to know what is the primary key, but if you heard about the primary key, right? So primary key should be one for each table later when we create the database. That's true. However, during the modeling, during the ER modeling, the key attribute doesn't have to be just one, at least one. No, instead it can be 0, it can be 1, it can be 2, it can be multiple. It doesn't matter because it's not related to the such a database system. Yeah, so that is the key attribute. Okay, so we pretty much done the up to the attribute entity part. The next is the relationship. So if you take a look at the description again, so sometimes it's confused like this part. Employee who manage the department. Actually, this is this one. I'm going to erase this. Then row here. So for example, employee Lee manage the HR. Employee James manage the IT. Employee the Potter manage the which department? The New York department. Okay. And so on. Like this, like this, like this. So these are actually when you meet your customer client, your customer will provide such information, not like this. But from this, the data you can find this is I already identified Lee James Potter. This is what?
Name.
Employee. So we already identify employee. And what about HR IT New York department? This is the department. We already identified the entity, department. Entity to blah, blah, another entity. So for example, here, the employee manage department. Lee manage HR. James manage IT, and so on. So at this time, we cannot, so it was a little bit risky to manage part of the what? The attribute, because there exists another entity. So this time, such a relationship is called one entity related to another entity. This time, this is called the relationship. So relationship, the combine two different entities. So another part, important part of the ER modeling is we are going to identify such a relationship. So from here, department, from here, what kind of relationship can you find? Manage. So between department and employee, we can find the manage the relationship. We are going to connect the two entities like that. Then this time, to represent the relationship, so we are going to use the diamond shape like this. Diamond shape like this. Okay, so that's the much better than this one, attribute manager, right? We can delete the unstable attribute, then we can create the relationship. But here is the thing. Just like the entity and entity type, actually this is the one relation. This is another relationship. This is another relationship. By grouping number of relationship, this is called the relationship type. So what we want to do is actually identifying the relationship type. However, just like the entity type, from now on, so we are going to use interchangeably relationship type. So if I'm saying, why don't you identify the relationship type? That means you are going to identify the relationship. So we have the managed relationship. Can you identify another relationship here? The department. Maybe not. The next. Each department control. So control, it was the not clear. So instead, we are going to create the control relationship like this. So we can erase this one. Then the control, we can create the relationship. It's a diamond shape and connect to corresponding the entity. Very nice. So can you find any other the relationship? Please keep finding. I will give the 2 minutes, and I'm going to do the same thing. So you can compare your answer with mine. Okay, so what do you think? So do I miss anything? So we can find works for between employee and department. Works for employee and department. Works on, oh, I missed this one. Works on. The employee may work on several projects. So employee project, there should be work on, works on. I missed this one. And connect this and connect this. Okay, so then keep track of direct supervisor and have a number. Then my concern is this one. So here, relationship, you can see the has the two entity, right? So one is here, in this case, the employee, another one is a department. What about the supervisor? Supervisor, supervisor. So what is a relationship? Relationship with what?
Employee.
Employee supervise another employee, right? So at this time, so it may be like this one. So Lee supervised James. So Lee supervised Patel. And Patel supervised the Susan. Like this. So which means employee supervise another employee. So supervise. So we can find the supervisor, the relationship. At this time, the direction is like this. Employee supervise employee, like that. Okay, so then this kind of the relationship is called recursive relationship, because employee supervise employee, supervise employee, supervise another employee. So it's a recursion the relationship. So how about the answer so far? Is this similar as mine? So if you can follow me, please give me thumbs up. Okay, very nice. So but I cannot see any thumbs up so far. Okay, very nice. So very good. Okay, then before we move on to the next part, there's one more important thing. If you take a look at the first relationship that we identify, each department has blah, blah, blah. Oh, here, employee who manage the department. So how many employees manage how many departments? Usually, how many managers do you have in a department? Department chair, one department chair. And the employee manage how many departments? One department. So, however, if you take a look at the employee works for, each employee works for one department. However, one department has how many employees?
Multiple.
Multiple. That's the difference. So we do better represent such a different types of the relationship here. So how many different types of relationship? First, just like the manager, it's a 1-to-1 relationship we have. And just like the works for, how many? One department has a many employee. Many employee works for one department. One to many or many to one relationship. Do you think we have any other? Yes, many to many. For example, here employee may work on several projects. That's the question from the David, right? So here, so one project may have many employees. And also one employee can work on many projects, like for example, this one. So Lee works on project 1. Lee works on project 2. Lee works on project 3. But there should be a number of hours, 10 hours per week, 20 hours per week, 5 hours per week, like this one. So this one is called many-to-many relationship. This is also called the cardinality. Such a cardinality. Have you ever seen such a cardinality of the relationship? It's from elementary level math. Do you remember this one? So here. There are two sets, A and B. It's like the match this, and this one is mapping to this. This one is mapping to this. This is a one-to-one mapping in math class. I think at least the middle school math class, you learned this, right? If we have this kind of thing, like this is the many A to one B. It's a many to one. What about this one? Like this. It's a many to many relationship. So we learned such a thing in set theory. So we are going to use the same idea to represent the degree of the relationship here. So one to one, one to many to many, and as a cardinality. So let's find the cardinality of the relationship. So what about the manage? Manage is the one of this, one to many to many. What kind of relationship is manage? What do you think? One of these, one to many to many. So for manager, just read one employee who manage the department, which means it's a 1 to 1. So such a cardinality will be written underline. So 1 to 1. Okay. So similarly, what about the works for? Each employee works for one department. One department has many employees. So it is many to one, one to many, right? So we need to write down which side is the many. Employee side or department side?
Employee side?
Yes, so many employee works for one department. Don't be confused. So sometimes the student, definitely this is the very good question for your midterm exam, but mistakenly, the student put the different way, like the many department, one employee. So this is my idea, it's my project. Just I always memorize many employees, many side employee works for one department. Then you will not confuse. What about the control? It's the one to one, one to many to many. One
to many.
One to many. Department is one and has control many projects. And what about the employee, the dependent? One to many dependent. And also, what about the supervisor? You have one supervisor and supervise many, one to many. That's it. So one to many. What about this works on?
One to many.
One to many. Why don't you take a look at this? But may work on several projects, many projects. And one project has many employees, which means
Oh, many.
many to many. So this one is the example of the many to many. So during the database design, many to many is the most important part. Why? Any idea why the many to many is important?
Most records.
Most reference. Why don't you take a look at this? David asked the number of hours per week, but it was not clear where it goes. It's the project side, employee side, right? Why? Because it's a many to many, like the number of hours, this one. So this time we can create this number of hours as an attribute of relationship, hours. Then it's clear. That is the reason the many to many can have the attribute also. So relationship type also has the attribute, but specifically the many to many has it. So eventually later, this many to many will be another table during the database creation. When you create the database, this many to many will be table later. Okay, so almost done. I'm very sorry to not to have a break time because I don't want to stop in the middle. So I want to complete all the one step for the ER modeling. So it's almost done. Okay, so mostly done. One more thing for the relationship. Then we will have a couple more things. So we identify the cardinality for the relationship. Okay, the R. And there's one more thing we have. Sometimes if you take a look at the description, even though I said that this description is very nice and easy, but if you read clearly, sometimes it said may, and sometimes it's not. So may means it's optional. So for example, when you see the employee who manage the department, why don't you go back to here, the manage. Department should have the manager, right? It's a mandatory. However, employee side, not all employee are manager. That is true. So if the participation on the relationship is required, mandatory, so mandatory participation will be represented by the double line, like this. It's a mandatory. Mandatory. Single line means it's the optional participation. So for example, manager, this side, the department must have the one manager, but employee side, it doesn't have to be like this. Okay. And what about this one? The employee supervise the supervisor. Supervise should have the supervisor, right? You should have the manager on your company, but supervisor doesn't, not all the employee will be supervisor like this. Okay. Do you think this is true? What do you think? It's a mandatory double line for this one, single line for this. Is it true? Correct? What about the CEO? Top level of HR organization. The CEO does not have a supervisor. It may have be audited, but that's so. Sometimes it can be the optional, so it will be safer like this. Okay, so if you can find the mandatory part, you can. But sometimes it's not very clear whether this is optional, this is a mandatory. If you are sure, like it's clearly mentioned about the may, then you can do optional. And if you can find some controlling department, that should any project should have the controlling department, so we can has the department control the many. Oh, it's the opposite way. So let me. So each project should have the controlling department like this. Okay. Any questions so far? I know this is not very clear sometimes from the description. So as much as possible, do not over the estimate. Okay. If that is clear, like clearly mentioned on the description or clearly identified from data, you guys can use such a double line. Double line will be very strong constraint later. So if you believe this is should be, then you can add such a double line. Okay. Otherwise, if you are not sure, be safe. So you can just use a single line like that. Okay. Then,
Excuse me,
yes.
just on the double line, it's related to the design of entity types and the relationship, but
Yes, later it should be the related. It can be
it's
used for
not, but
some
you don't do
constraint.
double line with the attributes.
Double
Those are-
line. Yes, that's a good question. So double line. So if we I think that you may imagine like the foreign key style. It's a constraint on the specific attribute, right? So, but we are not in that step yet. But the answer is this is such a constraint will be used for the number of different ways, like the non-null for the specific, the attribute, or foreign key, or the other constraint. So it should be here. But forget about that right now. Okay, we are just from the here description or data to the ER diagram. That's our purpose. Hey, very good question, but we will deal with it later. The last part is the weak entity. Weak entity means the department has a key attribute, project has a key attribute, employee has a key attribute, but dependent does not. So name maybe, but name cannot be the key attribute yet. However, if we know the related employee, definitely it will be key attribute. At this time, if you can find the identifying relationship means using this relationship type, go back, and employee. Social security number plus name. Then it can be if we add like the social security number plus name, it will be definitely the unique. So it can be key attribute later. So at this time, if the entity type, it doesn't have key. However, if you are using this relationship, then borrow the key attribute social security number. Then finally, it can, if this is the unique, then this time, this kind of entity type is called the weak entity. Weak entity can be represented by such a double rectangular. Then at this time, you don't have to write down the borrowed the key attribute. You don't have to do that. Instead, just the delete this one, and for the attribute, that is we just set aside as the candidate. It's the name, dependent name. This dependent name will be underlined, but this time dotted underline. Then how can you identify the name dependent? We can use the relationship. This time, this is called the specifically identifying relationship. To identify dependent, we should read the data from the entity from the employee. So in other words, the entity type belongs to part of the employee. Not part, it belongs to the employee entity type. So to be unique data, you should read the key attribute of the identifying relationship. One more time. So dependent does not have the key attribute. However, if we borrow the key attribute of the relationship, like the social security number, it can be key attribute. At this time, this kind of the entity type is called the identify relationship. No, it's a weak entity. So we can use the double rectangular like this. And also, if this relationship was used to identify the key attribute, at that time double the diamond rhombus, double rhombus to represent this relationship. It can be used for identifying of this entity. So double line, and definitely this should be mandatory, the double line. So then this is called the weak entity. However, in real the database design, you may not see the example of the weak entity a lot. Here's the question: why you cannot see such a real example when you design the database? What do you think? The reason is that when people see such a description or data, they just put the social security number over here. Then make the composite key attribute like this way. Then later, this social security number will be foreign key of this one. If you do not know what is a foreign key, just forget about it. So it's okay. So they put the social security number over here, then create the key attribute. At this time, this one is called the composite key attribute, like this way. Okay, so pretty much that's the whole process of the ER modeling. As I said, ER modeling is not complicated step, just to identify entity or the relationship. So first we identify the entity type. It's a thing. So like the department, project, employee, dependent. Then we are going to identify the attribute. Then that describes each entity type. Then we can use the over as a diagram. Then we can identify the relationship. There are 3 different types of relationship: one-to-one, one-to-many, many-to-many. Then we are going to identify the mandatory or the optional. In case of mandatory, use the double line. Okay. Then we are going to find if there is any, so we can identify the weak entity that doesn't have the key attribute. However, if we can find borrow the attribute, then make the key attribute, then the relationship is called the identifying relationship, and also this one is called the weak entity. So that's it. So that is the whole process of the ER modeling. So as you can see, it's not complicated. However, problem is, as I said, a lot of case, it depends on the situation, depends on the performance, depends on the customer requirement, which means it needs your experience or practice to be success. Okay, so let me erase this part. Oops. Let me erase this part and then move on as much as possible. Okay, then. So we complete all the process of the ER modeling, conceptual level design. So our goal of the conceptual design is such a well-organized ER. This is called the diagram. So this is the ER diagram. So our goal of the conceptual level design is using such a diagram. So we cover the most of them, except let's see the example of this. This is the textbook answer for this. I know my drawing is not so good, but you guys can understand. Mostly, let me erase this. Okay, so you can see I explained the most of them, but what about this one? Instead of the one to many, it's supposed to be the one to many, right? Many employee belongs to the department, but it used 1, 1. this one to many, many to many, many to one. It's not very clear. Okay. If you have the more detailed constraint, like for example, this is the min-max notation, minimum participation and maximum participation. So min-max notation means so minimum one employee, maximum one employee. And the department side, either minimum one department from employee side, maximum one department works for, which means at least employee at least one works for at least one department, maximum one department. Vice versa, 4 comma n means department should have at least the minimum 4 employees and maximum unlimited employee, like that. So 0 comma 1 means employee minimum 0 department manager, which means the no manager, or maximum 1 department manager. However, this side, the department side, the minimum 1 the employee as a manager, maximum at least at most 1 employee as a manager. So min-max notation is more details for the such a constraint. I will explain one more time the next time. So this is about the min-max notation. The only thing I do not explain here is the dot, number of employees. Think about it. If we can calculate the number of employees for each department, actually this is a calculation, it's not attribute. However, if you're the customer specify, we want to access the number of employee a lot, so we try to manage such a number of employee per department as an attribute. At that time, you can create such an attribute. This is kind of attribute is called the derived attribute. You are able to calculate such a derived attribute. It's not actually in your data set or description, but in your application. From time to time, you are accessing number of employees per department. You are going to create the attribute. That is the derived attribute. Then I think that I explained the most of the concept of the ER model. Then there is a homework. No, you don't have to do that. This one, just the read the university and then try to understand this diagram. If you are able to read and understand this diagram, then imagine that this kind of description pretty much okay. Here is a homework. By next week, I know we didn't have enough time to nicely draw this ER diagram. Why don't you go back to the description again? Okay, where is it? The company database, and read the line by line and prepare the scratch paper. I do not have the scratch paper, and nicely draw the ER diagram for the company database, the step by step, by following the step by step. Then next class, the beginning of class, you can just show me like this way. You don't have to submit, okay? Just handwritten, handwriting, or if you want, you can use the program to draw this diagram, the company database diagram. So then you can print out or you can show the screen to me the next class. Okay, it's just for your practice. You don't have to submit.
What program can we use to do it?
You don't have to use, if you do not, what I'm saying, the program, I'm going to show the couple of example, but you don't have to use such a modeling the program like the Microsoft the Visio or the something others. The PowerPoint, you can use such a thing, but mostly the drawing diagram is not important. Instead, you guys need to understand the step procedure of the ER modeling. So you can use the handwriting. You don't have to use the program. Forget about the program. Just use the pencil and the sketch paper and nicely draw the ER diagram. Okay. You don't have to use the program so far. Okay, so that's the ER diagram. Let's quickly finish within a minute. Let's quickly finish the chapter 3. So we covered the most of the thing, and blah 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 blah. and we finally did this the diagram. Okay, so you can compare this diagram with yours. Then by next class, why don't you nice step by step remind such a step, and see your answer is correct. If not correct, correct it. Then the next class show your the best the diagram to me. And I think that I missed a couple of things here. I going to explain again min-max notation again next time, and also the alternative diagram, and also the NRA, the relationship. I'm going to explain the later, the next class, before we start the ER model. Then here's the last topic today's class. So for the modeling tool, the Mila asked me what kind of software you can use. There are many software like here the ER Studio, DB Tuition, and so on. The even PowerPoint and the video and the rational rules and like that. So there are many different software for your design. So for your practice, we are going to use the two. Let me erase everything right now. Oops. Or not this one. Oops. Because of this. Let me see where is it? Yes. So if you take a look at the DB exercise lab book, and on the page the 11. So let's move to the 11. So by next class, among the different modeling tool, so I'm going to use the Irwin software. Irwin software you are able to download from this website for academic edition, and also you can request the academic license. But unfortunately, Irwin is only for the Windows user. So if you are using Mac, so you can download any other the data modeling tool. So I am suggesting if you do not have any preference, I'm suggesting to use the MySQL Workbench. So why MySQL Workbench is available, the MySQL website, or click this one. So then you can install. They are different, but basically they are doing the same thing, ER modeling design. So you don't, if you want, you can study by yourself, but otherwise we can practice together in the first exercise lab last week. By next week, install at least one of these, the software on your laptop. Okay. If you have any other preference, it's fine. But in this class, for the exercise, I'm going to use either the Irwin, basically based on the Irwin. But if you are using macOS, you can use the Workbench. Okay, so that is the second thing. And for the project, so first phase is due by the February 5th. Until that time, it's just a project initiation. So what you guys need to do is you are going to define the problem. So what is the problem? So you are going to implement the course registration system. You already know how to register the course. Then sometimes you complain that it's a terrible system or that it's good. So based on the requirement, you are going to design. So first, the student login the system. So you should have something login the problem, and then there should be something the course list. Then student can select the course. Then there might be a section if you believe. Then so on. So I'm not going to give the specific. I said something the wrong information. I'm going to modify this one. So based on your experience, you are going to design such a course registration system. Okay. At that time, the second phase is just the problem. You can state what kind of the functionality you are going to implement, and select the list of the course by the major, or by the department, by the class, by the grade, and something like that. Then there might be the information about the instructor and so on. It's totally up to you. So you guys going to the design the problem. Okay. Then the third one. So instead, we don't know how to use the SQL. We don't know how to use the database language. Instead, you are going to formulating the function in English. Like for example, a student can log in, sign in the registration system. And the number two, the student can list the course available. Then number three, student can select the course take. Then the number four, student can request override for the course that the need the prerequisite, something like that. Okay, so it depends on the problem that you define. Then you are going to make the realistic query in English, not the database query. Later, obviously, the realistic query in English will be translated to the database language after you finish the SQL part. Okay, so this is step 3. Step 4 is that if you have any assumption on your system, you can specify. Like for example, in my system, I'd like to implement the payment, tuition payment, but how can you do that? So you are assuming the payment will be done separately. Then you don't have to implement that part. Okay. So such an assumption you can include over here, or the limitation, like the course always limited by the 10 students, like that. Then that will be the kind of the assumption of your database, like that. Okay. Then you can submit all the information as a document, and to the Moodle. That's it. Okay, so that is the phase 1, which is due on the February 5th next week. So we may have a chance to talk about the more after you guys start the phase 1 during the next meeting. Okay. 2 minutes over. Any questions? There's no homework except drawing the ER diagram on the scratch paper and show me before when we start the next meeting. And otherwise, please start earlier for the project, phase 1. And if you have any question, we may have a time to talk about the project next class. And also, please be ready for the data modeling tool. So download either the Workbench or the data modeler by the next class. Then we can start the first exercise. Any questions?
What are the things that we have to download?
You can go to the exercise lab document. Then I put the link to download the software. So if you are using Windows, you can download the Orwin software. If you are using MacBook, you can download the MySQL Workbench.
Okay, thank you.
Okay, I'm so sorry. Just to clarify, so what do we need to do before next class? Download the software for data modeling.
Hmm?
We do the second part of what we were doing in class by ourselves on a scrap of paper to show you. That's if
You don't have to submit, just to show me the beginning of class. It's for your
Right.
practice.
And then thirdly, we don't need to submit it on class day, but we probably should be starting to work on project phase 1, which is going to be due Friday after our class.
Sure.
Is there anything else due on Friday other than project part 1?
No.
Okay, thank you so much. I'm sorry.
Okay. Okay, thank you. And good evening. And also be safe. We will see again the next week. Thank you.
Professor.
Yes.
Thank you.
Thank you.